Elixir Flow. Have anyone heard about it before? And I'm not considering reading the title of this presentation, I mean before that. No? Nobody? A little bit. Okay, so basically I can say anything I want, that's no one there, okay. So just present myself again. Thanks Nicholas to give me a hint how to say my name here. So it's Renato. I work as a software developer here in Mirigo, and that's my things for social networks. Basically any social network that you put there, you're gonna find me, including Google+, but don't go there. All my passwords are there, so please. So Elixir Flow. In the documentation, the official site starts like this: computational flows with stages, which means absolutely nothing. The first time I read it, I have no idea what it is. Basically what Elixir Flows does is this. It's map reduce, right? Now the buzzwords start to make a little bit more sense. You have a collection of data, you do some processing, some transformations, mapping, filter, things like that, and then you have a result. You're gonna have a reducer that's gonna grab all the results. Okay, fairly simple. But Elixir already does that without Flow. We can use enums to do that. Also came from the documentation, so basically I'm counting words inside a file. I have a file, then I'm gonna flat map, splitting by break line, by space. I'm gonna reduce counting the words from that, put it on a list, right? It works. Enum has a problem that if my file is too big, it's gonna load the entire file in memory once, and yeah, okay, that's not nice. But then again, Elixir gives me streams, right? Streams basically a recipe, and it's gonna start actually processing when I do the reduce. So what the hell, why Flow? Because basically Flow is gonna do this. It's gonna use multiple cores. So the part of processing, what you have to do, is gonna be done in a different, using all the cores that you have available actually. That's quite nice. It does that using this guy, GeneStage, which is something that José Valim wrote about it a couple of years ago when they launched it. It's something really nice, really cool, but I'm not gonna talk about that today. Flow, it's above this. It uses GeneStage underneath. You can do much more with GeneStages than just Flow, but Flow is simpler for mapping reduce. GeneStage is a little bit bigger. You can do more things with that. It's more flexible, but you have to write more code. But producer-consumer problems, if anyone ever heard about it, GeneStage is really nice. And all the examples that I gave so far, I have a file that I'm counting words inside it. It's what we call bounded data. So it doesn't matter if it's small or big, but I have a beginning and an end. It can be huge, but I know the size of the problem, the size of the file that I have to process. But then again, I'm not gonna talk about bounded data tonight. I'm gonna talk about unbounded data, which Flow also works to process. The reason why I'm not talking about GeneStage and bounded data, I'm gonna say at the end, but actually José Valim has a presentation about that, and it's much better presenting that than me, so go ahead and watch the video from his presentation. It was the keynote for ElixirConf, I think, in 2016. But he doesn't talk about the unbounded data part of Elixir Flow, and that's what I'm talking about today. What is an unbounded data? It's a data that doesn't have a limit. You don't know the end of this data. And what is that in the real life? Yeah, it could be like Twitter. If your customer goes to you and say, okay, I want to have all the tweets with this hashtag on my web page, and Twitter's gonna give you a stream, something that doesn't have an end. And every time someone writes a Twitter with this hashtag, is gonna give to you. And how many tweets do I get? I have no idea. It's gonna be there forever. Another thing, it's like, imagine Google Maps or Waze. How many cars are driving right now using those apps? And when it's gonna finish? When can I grab, like, I want to know the average speed of some street with all the cars that are driving there using my app, but how many cars do I have to wait until I say, okay, now it's finished, now I can calculate the average speed of that street? It's something that you don't know, you don't control. The data just keep coming every time. You have an upload photo from your app, from your mobile phone, your customer goes and upload photos. Okay, how many photos should I wait until I do some processing with that, resizing or filtering for unwanted content, you have no idea, because the customer is gonna keep uploading photos and you don't have an end date, blah, I'm gonna wait forever, and when they finish, when they stop uploading, then I'm gonna start processing. Those kind of things are unbounded data, so data that you don't have a limit. And most of it is gonna call event streaming, because you have a bunch of events happening and it's gonna stream to your software. It's gonna give you this stream of a lot of events, a lot of things that's happening. The car that starts driving with Waze or Google Maps, the tweet that's just arrived, the photo that just arrived. That's the event streaming. And where you can use this, and actually I used this not with Elixir Flow, but before that we wrote it partly in Java, partly in Node.js. It was for real-time monitoring your software, but not monitoring the level of the server. I don't want to know if the memory is high or the CPU is high. You have already tools for that. It's in the concept of the business logic, because our customer needed to know how many users are using the software right now, and it was on a website, so I cannot use like Google Analytics, another tool that's already there. We had to build our own. And he also wanted to know what the user is doing inside my software. And in one section, from the time he logged in until he logged out, what he did inside. And what we did, an event streaming. So every step of the way, we send an event to our backend, or it was in the cloud, but we sent to our backend saying, okay, the user did that, the user did this. And we process all this together, group it, and process at the end. Real time, because it's not real time, it's going to have a couple of milliseconds, but it's easier to implement than actual real time monitoring. And we were able to say to give this information to our customers, saying, okay, right now you have around X customers using your software. What they are doing, what their places inside your software, inside your website, what they are doing more, what they are doing less. If you do A/B tests, you can know, okay, this scenario, it's working better than the other one. There is one thing, guys, if you have any questions, you can stop me anyway. You don't have to wait until the end, all right? So, okay, we are back to our stream. How do I convert this to use Elixir Flow with unbounded data? Instead of a file and grabbing all the information, I want a stream, I want unbounded data. I have something that doesn't have an end. If it doesn't have an end, I cannot use like an reduce and put it on the list, because it's never gonna end. It's gonna keep on the reduce forever. And how can I start organizing? How to group a little bit all these events, all this information that's coming from the stream, so I can actually process, see, and make some sense out of it? We use Windows. Yeah, we are gonna download Windows Vista. No, sorry. This is the Windows for stream processing. You have your stream. You have all the events passing, all the information's coming. The Windows is gonna give you this, a window that you're gonna look and kind of freezing, saying, okay, I'm gonna process these events inside my window. The other ones that will come, it's the next window. The ones that already passed, it was the previous windows. So I can group, I can make some sense out of it. But there's not only one way to do this grouping, you have more than one. So Elixir Flow gives us a couple of types of windows that we can use. The first one, global window. It's the most basic, and actually just one window that's gonna stay forever for everything you wanna do. I already explained that, okay, this is the default, because if you work with bounded data, that's okay, you don't need multiple windows, only one until the file or your data is finished. I process everything in one window. That works. For unbounded data, not that much. So we have count window, which if you're gonna use, you're gonna say, okay, I want a window of 100 events, 200, 1000. It's up to you to choose. So Elixir Flow is going to start counting all the events that arrived until it reached that number, and then it's going to give you, okay, here's the window with all the events that is inside. And as soon as this window finishes, it's going to start another one. You have session window, which is kind of nice, not hard to explain, but Session is actually, if you think about the section of a user inside a website, inside a software. The moment the user log in and when it log out, you had a section. And if the same user comes back to your website and log in again, you have a different section. And basically that's it. You're gonna give some information to Elixir Flow saying, okay, I want a window, a section window, and here's the function that's gonna extract the section from the message. So every message, every event that arrives to that window with the same value returning from that function, it's gonna group to you. It has to be careful with this because you can have some events taking longer to arrive. And if you start multiple window sections, the memory is gonna be scaling really fast because it's gonna wait until some time that it's gonna say, okay, probably there's no more events coming from this section. So the section is nice, but you have to take some cares.
Is there a timeout function, or is that something you should include in a session calculation method?
There are ways inside the Elixir Flow to say, okay, that's it. That's the maximum that I'm gonna wait between one event and the other one. So I have the sections coming, events from the same section, and I'm gonna say, okay, if I receive one event and I don't receive another event for the same section for the next 3 minutes, then I'm gonna close this section. Fixed window. It's basically time window. So I'm gonna say I want to see all the events from the past hour, and every hour I want a window, every minute, every day, every 2 hours. It's up to you. And we have the periodic window, which is also based on time. It's also based on I want the event from the last hour, but the difference with the fixed and periodic is this concept, because you have the events, and it's a best practice to put a timestamp on the event when the event happened. So the user upload the photo from his app. It's nice to put on this event, say, okay, the user uploaded on this timestamp and gonna arrive to your server, your flow, with this timestamp. But imagine that you have like a real nice app that works offline, and your user is flying from, let's say, Brazil to Canada, and the guy uploads a photo in the middle of the travel. And yeah, of course it's not gonna upload because safety is gonna be with the airplane mode, and a couple of hours later it's gonna disable the airplane mode, then the upload is gonna happen. So you have a difference between the event time and the processing time. The event, it's when the event actually happened, and it's this property that the fixed window is gonna use. So you want a window based on the event time. It's going to be the fixed one. You want a window based on the processing time. It means when the event arrived at your flow, then you're going to use the periodic window. That's the main difference between both. It's the timing of when the event happened or when the event arrived at your server. So code time, and I hope it works. I practiced this the entire weekend. Shit, no, I don't want my Spotify. Yeah. It could be worse than Spotify. I have to.
Sorry, I have a question.
Yeah, sure.
What kind of music do you listen to?
Right now I was Volbeat all the way through. It's amazing. I love this for the afternoon, especially when I woke up 4 a.m. because I work in Quebec and I need to stay awake. So.
All right. That was the most important question to know.
I have to agree with you. It's really important. You can learn a lot from that. It's big enough? Yeah, it's big enough. This is on my GitHub. I'm going to give the link at the end. But basically what I'm doing, the dev module simulator, it's going to simulate the events for me. So I have a stream that's going to repeat it to the infinite, doesn't end, and every time it's going to be called, I'm going to generate a tuple with a type of vehicle and a speed. Yes?
Can you make it bigger?
I can try. I have no idea how to do that.
Comment plus?
No, comment plus, no.
Push to.
What? No. presentation mode is...
I think he might be trolling you.
It works. So, I have my simulator. Imagine this like you have on the street or on a highway, you have a sensor getting all the vehicles that pass through it, and I'm gonna measure the speed of the vehicle. And I can also, based on the weight, I can measure if it's a car, or if it's a motorcycle, or if it's a truck. My simulator is just gonna give me a stream, an infinite stream of data, and randomly I'm gonna give if it's a car, a truck, or a motorcycle, and the speed between 70 and 120. I'm doing the random 0 to 1 just to put some errors inside. So imagine that my radar, my sensor sometimes cannot get the speed of the car or the vehicle. So it's gonna give me 0 saying, okay, this vehicle passed through me, but I couldn't measure the speed. So it's gonna give me some error. And here underneath we have our actual flow code. If you take a look, it's not that different from the enum or stream. Basically, I'm defining some windows. I'm gonna show you guys the difference between those three, but for now I'm using the window count 100. So it's gonna wait for 100 events before it's gonna give me the result, before consider that window finish it. I have from enumerable passing my string, so it's where it's gonna get the data from. I have one step of processing, which is a filter saying, okay, every message that arrives with the 0 speed, I want to discard. I don't want to use it. I have a partition that's gonna explain in a minute. But in this guy is where I say, okay, use this window that I decided. The key I'm gonna explain also later. And this stage is, yeah, it comes from the GeneStage underneath. You don't have to say it. By default is 4, and it's gonna calculate it if you needed more. I'm passing 1 because to show the results is just gonna be easier. And then I have my reduce function, which here is basically getting a map, counting by type. So I'm gonna count all the vehicles that passed through, that I received the event. I'm gonna have a total speed, so by type also, so I'm just summing up, because in the end I'm gonna do a simple average of that. So I'm gonna split in the total by the amount, and I have the average speed by type. And at the end I have this guy over here. It's on trigger. Why I have this? The question that you made about the time in the section. The trigger is the guy that is gonna be called when the window is finished. Because I have the reduce. The reduce is gonna keep my state. But do you remember the problem of streams and enum when you have unbounded data that the reduce is gonna run forever? Yeah. The reduce here is gonna run until the window is finished. And when the window is finished, my trigger is gonna be called. And on the trigger, I will receive the state from the reduce. So this guy over here, I'm just printing the state and passing through. Because I'm passing back here is not gonna change that much, but it's another concept called watermarks, because imagine that you have a window of 1 hour. I put the periodic window, I'm gonna wait for all the events in 1 hour, but I don't want to actually wait 1 hour to start seeing the results. I want to follow through the results minute by minute. So I can say, okay, window, your fixed time, 1 hour, but give me a watermark every minute. And also it's gonna call the one trigger on that. The difference is gonna have another parameters where I can verify that, okay, the on trigger was called because it's a watermark or because the window is finished. And at the end I just have the flow run, because since this is unbounded data, I have to keep the flow running indefinitely until the end of times or the end of the memory of my notebook. And I hope it works right now. It's big enough, or is everyone can see? Here the comment plus works, so that's why I'm asking. Just gonna clear it easier. So I'm start running, and I'm gonna stop running. Nice, it's cutting right. Okay. Shit, there's a spoiler of the slides. Okay, so every time I have trigger, I'm printing the map that comes from redos. Okay, so there I have the average by type, I have the total amount of cars, total speed of cars, motorcycle with tracks, and I have the total speed. The stage that I put 1 here, if I change it, if I remove it and leave the 4 by default, or if I put anything else, it's gonna give me the result it's distributed. Instead of having one trigger with all the information, I'm gonna have multiple triggers with different informations. Basically was that, but I'm gonna explain later. And this is our window count. So if you take a look, the total amount of vehicles inside each trigger is going to be 100, because it waited 100 vehicles to call the trigger, to consider that window closed. I have everything I needed, so here's the window, the reduce is going to work, it's going to call the trigger after. Another thing that if you realize is that the total speed, or the total amount of each vehicle, it's restarted for every trigger. So when I change window, when the window is closed, the state of the reduce, it's also restarted. A new window, a new state. Because it's not something that you want to have like an infinite state for everything that happened in history. It's not nice. You lose most of what Elixir Flow is. If you want to work with unbounded data, you have infinite data, so you don't want to keep the state for the infinite in your memory. So let's gonna change this for those two guys. Now I'm doing a global window, so I have only one window for everything, and then I put trigger every 100, because if I don't put that trigger, it's gonna have the same window, they're never gonna call the trigger, and we are never gonna see the results. So I'm gonna trigger every 100 events that it accumulates, it's gonna call the on trigger for us. But if you take a look at the results, it's also gonna call every trigger, every 100 results, but it's gonna keep the state from the past window, or not window, but the past time it called trigger, because it's the same state that keeping going and going, it's the same window. And the third type, it's the periodic, which is based in time, but in time of the processing, not in time of the event, because anyway my events here doesn't have a timestamp, I could put it. So which means like every 3 seconds it's gonna give me one answer. The amount of vehicles inside each answer is gonna differentiate it, because it's only gonna count on time. It's gonna wait 1, 2, 3, all the messages that I have right now, here it is. Which one is better? It really depends on your business, what you wanna do, what do you need, what makes sense to your business. And can come back to presentation.
Just a quick question.
Yeah, sure.
I guess you're trying to explain the window, but what happens if you have like a type error in one of those functions, or like it blows up somehow on like trucks, for example? Well, can you recover from that within your flow? Does flow give you anything?
No, the flow is gonna stop. Like any code of Elixir is gonna stop if you don't treat your errors. This is just for presentation, so but getting the presentation from Nicholas, don't put the logic, what you want to do with the events inside, put it outside, and then you can handle the errors. Because also it's gonna, depends on your business logic. If you have a message that is completely bullshit, it's something that you cannot even parse. It's in a format that your software doesn't know. You can do a couple of different things, and it's up to you to decide what to do. You can put that on a database or in a different query in a different place, so you can handle that later, or just log it, or just ignore the message. So it's always inside your filtering, your steps that you have to decide it. Another thing that can stop a flow is if it tries to fetch more data from the stream or from the producer and it cannot find, then it's gonna stop the flow also. So underneath there's the GeneStage doing back pressure and blah, 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 a bunch of things that it's really nice to know how it works, but José Valim has the presentation which explains this much better, but basically if it tries to fetch more data and it cannot find, it comes like empty, it's gonna be considered like, okay, it's a bounded data and then I finish processing everything. So even if you want, like, your messages are not as constant as your window, you also have to code yourself something like, okay, I'm gonna let this flow finish and start a new one when a new message arrives, or I'm gonna try to keep this one running, waiting for the next one.
So basically, like validate, make sure the stuff coming into your flow is proper before you start it.
Not really. You can have like the first step on the code. Here, the flow filter, I'm basically doing some sanitization. I'm cleaning the messages that are unwanted for me. I don't want to treat those messages inside this flow. I'm going to talk a little bit further about some best practice. This is going to be a little bit clearer, but like this flow is to calculate the average speed by type. But with the same message, I can calculate something else. I can calculate, okay, in this point of where my sensor is, I want to calculate the average total of the average speed, not by type. Or I can put the timestamp and say, okay, what time of the day the cars here, the vehicles here, are more slow than the other time. This is not this flow. You're gonna have multiple flows, send the same message to all of them, and let them work for you.
I don't know the answer, but I'm going to just say something about that. But I mean, about your point saying that if ever there's something in my code that causes my flow to crash, depending on the setup of your supervision tree, most of the time it's going to end up restarting your application, thus restarting your flow. So you might have a log of something saying, the application crashed for that stack trace, but in the end, your Beam application will probably be able to recover from that crash and restart the flow until the same exact case comes true and causes the exact same error and crash the process again.
Yep.
So that's usually why the let it crash sentence comes from, saying that the supervision tree will handle that crash and restart the process.
If I had to add something, just like in the case of flow stream processing and things like that, let it crash, but try to log why it crashed, because if not, it's gonna keep crashing and crashing and crashing, and what the hell? And especially if you were getting the information from third parties, it's not your API, and sometimes they just change the format of the message and then you. But okay. So, okay, there was the code. So basically, I'm come back to the drawing of the flow, and here's the code with the steps from flow that we just did it. I have the from enable to get my data. I have the filter that I'm doing, the partition that I'm gonna explain, the reduce, on trigger, run. It's the same steps that I had. I had my circles to explain flow. So basically what I have, we have one thing that is called producer. It's the guy that's gonna give you the data. It's gonna produce it and give it to you. It can produce itself, or most of the time it's gonna fetch from somewhere else. Could be internally in your own software, in your own domain, or can be something external. You have the process part of the map reduce. So Elixir Flow basically is gonna create a lot of GeneStages and gonna give the work to do, my filtering, if the speed is above zero, it's more than zero or not. It's gonna be split through all the cores. And then I have my reduce part, which is the guy that's gonna grab all the results from that, accumulate all the data, all the states that I have. And here's the partition. What partition does is, if you have multiple GeneStages and you get your message and spread across all the cores that you have, when you try to reduce, Elixir Flow needs a way to know, okay, the car, who is accumulating, who is reducing the type car is this GeneStage. Because if I don't use the partition, it's gonna give to any reduce. It doesn't know. Basically what partition does for flow, it's mapping all the GeneStages that are processing something with the GeneStages that are reducing something. And it's gonna create a map to say, okay, who is reducing the cars? This GeneStage. So it doesn't matter which blue circle is gonna process the message, is gonna send to the right yellow circle to reduce it. How Elixir Flow knows that? This guy over here. When I do the partition, I have the key. It's basically a function saying, okay, from the messages that you have, this is the guy that you're gonna use to map to which reducer you're gonna use. If you don't pass anything, Elixir Flow is gonna hash the entire message and use that as a key. In our case, it's not nice because the same car with different, the same type with different speeds is gonna go to different places. In this case, I'm just saying, okay, the key, you're gonna map, you're gonna read those together by type of the vehicle. So it knows internally which reducer is gonna reduce the cars, the trucks, the motorcycle. That's what partition does. And usually, most of the time, you're gonna have these 3 steps together. You have the partition, you have the reduce, and you have the on trigger. Usually they're gonna be called in this order for sanity of the developer, I would say. Because without that, you may have some bizarre errors without knowing which message is going where or why it's not considering. So some conclusions about this. Elixir Flow is another tool in our tool belt. It's different from when you are learning Elixir functional language that you can say, okay, from now on, I'm gonna write all my softwares using Elixir, all my softwares writing functional code. Elixir Flow is something that, okay, it's nice to know that exists. When I need to do some batch processing, which is bounded data, but okay, it makes easy for me. I don't have to think about how I'm gonna break a huge chunk of data that I have to process. Elixir Flow is gonna do that for me because of the GeneStages and back pressure. If I have some uploads, that is something very common that you have in our software, and usually we don't have a sanitization like, okay, the user is gonna upload a photo, but that photo has what I need it to have is the size, the format, and all this. Usually we are gonna write a software like one by one. I have one request with one photo and process that photo, then I wait for another request, and so far, so forth. And Elixir Flow helps with that because you can have like a query, RabbitMQ, or if you go to Google Cloud, PubSub, or Amazon, you have SNS, SQS with all the uploads, and you start consuming these and processing. But it's not like you're gonna write your entire software using Elixir Flow. It's for one specific thing that you're gonna do. It's basically like Ecto. But it's a kind of way of programming that usually we are not thinking about using frameworks like this, libs like Elixir Flow to do these kind of things. Usually you go for the most easy one without realizing that we have another thing that's also easy and it's gonna give you much more scalability and control of what's happening. Flow is in memory, so while it's keeping the window, counting and grouping all the messages for you, it's everything in memory. So for one side, okay, it's fast, but if you have a crash in your server, you just lost the entire Windows, all the messages that it cannot process, and everything else. So thinking about that, keep your flow small. Like I was explaining to you, that flow was to calculate the average speed by type. If I need to calculate something else based on the same message, I'm not gonna put in the same flow. I'm gonna send to another one. One of the reasons, because it can be processed in parallel. I can have both running in different servers or in the same server, but concurrently. But the second one, it's small, so my trigger is gonna be called faster, and I can persist the data that I read, process, I read, reduce it. And you have always to think like result speed versus result precision, because if I put a fixed window of 1 hour, that's nice. But if with 55 minutes the server crashes, damn it. If your user arrive at you, okay, and how we were doing in the last hour? Oh, I don't know, you have to wait 5 more minutes because I only have the data after 1 hour. It's nice because 1 hour you're gonna have more precision in your result. But if you want the results faster, you have the triggers. But you have to think about, okay, but my triggers If it's 1 hour window and it runs every minute, the first 1 minute, 2 minutes, 3 minutes, it's not enough to take a look of the entire hour. I'm calculating the average. If I return to 0 every time, my first minutes is not gonna give me some information that maybe it's useful.
You have overlapping windows, so like every minute you can get the last hour.
Like a rolling window.
Yeah,
Like a rolling
they
window.
overlap each other all the time.
Yeah, that's a great question, and I finished the presentation, but I'm gonna answer that one because if you see the presentation from José Valim talking about Elixir Flow and GeneStage, is gonna mention that most of this part of Windows triggers, watermarks, all these concepts, they are not creation of José Valim. He grabbed it from a guy called Apache Beam, which is a specification of how to deal with unbounded data, which has all this and a little bit more. And Google is behind it, helping. But of course, so the first implementations are in Java and in Python, and it runs in the GCP smoothly with a lot of things. But all those concepts of Windows triggers, José Valim took from Apache Beam. And he says that because it was really nice to work with that. In Apache Beam, you have the rolling window. Like I want a window with from the last hour. So every minute it's gonna update itself with the last hour behind it, and then you have the same event belonging to different windows. Elixir Flow so far doesn't have that. You can have some similar behavior using the triggers because, yeah, you can have like a global window with the triggers. You can try this, but you have to reset your state manually inside your trigger. Like after 1 hour, I'm gonna reset it, restart my state, so the redo is gonna start from 0 again. Or you can have a fixed window of 1 hour, and in the triggers try to keep that. But if you want the behavior to show to the user like the last hour of things, I would go with any of the windows that you want to. On my trigger, I would persist this like in a database, or it doesn't matter, and then I have a report that's gonna read this. So every minute I'm gonna have the information there, so the report can go there and see, okay, the last 60 minutes, it doesn't matter, and the next minute is gonna have the next one also, but it's outside Flow, it's after Flow, it's where you persist and how you deal with this data after, because right now Flow doesn't have a sliding window like Apache Beam has. If you want to implement it, it's open source.
Sort of in that.
And sorry, that will have to be the last question as well.
Okay.
Oh, okay.
Just in that line of thinking, what is how do you handle the case, or is there a handling for the case where your triggers are firing faster than the time it takes for your MapReduce to finish processing?
It's an excellent question. I have no idea what's gonna happen. I'm trying to think in here, but probably, yeah, probably. If I had to guess, the state that you're gonna receive on your trigger, it's gonna be the last one before the. Let's say the reduce is in the middle of some processing. You're gonna receive the state immediately before that. Okay. If I have to guess, because even. Imagine like on my trigger, I'm gonna send the information that I get to a database. I'm gonna persist that on a database. This takes a couple of milliseconds, and while it's doing that, another window already started and my reduce is already working for that window. So that's one of the advantages that you have multiple cores doing that. So my trigger can do something that's a little bit slower than the rest. Internally, I think Flow is gonna query those calls, but yeah, it's a.
So there's partitioning between what the trigger is doing and what the partitioning and mapping.
There's a separation between what trigger is doing and reducing is doing.
My guess is that it's actually spawning processes in the background, so
Yeah.
it doesn't matter if the window is not finished processing, because the process is going to die when it's done.
Underneath Flow is going to use GeneStage, and if you go to the GeneStage documentation, when you create a GeneStage, you can say that that GeneStage is a producer, a consumer, or a producer-consumer. And underneath Flow, everything is that. Or is a producer, which is the beginning of the thing. Then you have the producer-consumers, consumer produces, which is like the filter that gets this information, do something, and produce to the next layer, and so forth. So yeah, it's gonna spawn these GeneStages for you, and they are gonna concurrently work. But probably, yeah. I know that if Flow tries to fetch data and there's no more data, it's gonna stop. But I don't think like if the trigger waits for the reduce, it's gonna stop the flow also. I think it's gonna finish everything that is in reduce right now and give it to the trigger, and then it's gonna stop. But I'm guessing here.
It will probably stop to accept more events before it ends.
Yeah, because actually, because GeneStage is not gonna grab the events like one by one. GeneStage is gonna use back pressure, so actually the producer waits for the consumer say, okay, I'm almost finished processing what I have, give me more, and then the producer has some time to produce that. So you can pass as parameters also when I'm starting the flow, but if you don't pass it, the GeneStage is gonna use the defaults. But it's gonna get chunks of data for you, like you have the min and max, and the min is not 0. The mean is like, if the max is 1000, the min is gonna be 500, because the producer is gonna get 1000 events, 1000 messages, and gonna give to the consumer, and the consumer start processing. And when it reaches the 500, it's already going and say to the producer, okay, I'm in the 500, start producing me more. And then the producer goes and tries to produce another 500. So what it tries to do is not keep your GeneStage waiting for, okay, finish the 1000, I'll produce me another 1000, it's gonna take 1 second, and the GeneStage stay there 1 second waiting. So they have this kind of balance. It's not a buffer, but the min and max, and the min is not 0 because of that. So
Yeah, perfect. Thanks very much.
that's just. Those are the links that I said about the keynote about Elixir Flow and GeneStage. The blog from Elixir Lang, wrote by José Valin, also announcing the GeneStage. The docs of Elixir Flow, it's amazing. You have more lines of documentations than code. And my GitHub with the code that I just demoed for you. That's it. Thank you very much. Have a good evening.